Hi everybody, 11 Institute welcomes all the students of Standard 10 to the subject Science, chapter number 11, and this is video lecture number 6. In the previous video lectures, we have discussed about the phenomena of light that occur due to the prism. We have seen the refraction and dispersion of light due to the glass prism, and in today's video lecture, we are going to see a new topic, atmospheric refraction. Fine. So before jumping into the topic, let us have an overview of this topic. Just don't be confused with this. Many of the students are confused till the end of the exams that what is actually atmospheric refraction. They somehow mother up. But it is quite clear. The idea is quite clear. Just separate these two words: atmospheric and refraction. Right. Let us first focus on the meaning of refraction. What is refraction? We have studied that suppose there is a surface separating two media. Right, here suppose there is medium 1 and here suppose there is medium 2. Here suppose there is a normal on the surface. Now, when there is a light incident at the surface, right, this is surface. This light will not travel in the straight line, but it will either bend towards the normal like this, or it will bend away from normal. Right. So in short, when I want to say in a phrase of words that what do we mean by refraction, I can write bending of path of light. Bending of path of light. And when does such a bending occur? When the light travels from one medium to another medium. Then, in case of refraction, we further studied that the medium is having its own refractive index. Right, this media can be given a tag of either optically denser media or optically rarer media, right? Optically rarer and optically denser. And then we came to know that based upon their optical density, the media are having their own refractive index. The media are having their own refractive index. Fine. So now refractive index of a medium can be more, refractive index of a medium can be less. When light travels from a medium of higher refractive index to a medium of lower refractive index, it will bend away from normal. The light will bend away from normal. And when light travels from a medium having low refractive index to a medium having high refractive index, that light ray will bend towards the normal. We have studied this in very much detail in previous chapter, chapter number 10. Right, so there is a link between these two chapters. Sure. So ultimately, what do we mean by refraction? Bending of path of light. When light travels from a medium from media having different refractive indices. If there is a change in refractive indices, there will be change in path of light also. This is the common meaning of refraction for us now. Right, bending of path of light when it travels from the media of different refractive indices. Now let us focus upon the word atmosphere. Let us focus upon atmosphere. Fine. Suppose this is the surface of earth, and we know that earth is surrounded by atmosphere, the mixture of gases. But the atmosphere has many layers. Suppose this is first layer, second layer, third layer, fourth layer. The atmosphere is having many layers. No, stratosphere, troposphere, mesosphere, etc., etc., etc. There are different layers. Now, these different layers of atmosphere have different refractive indices, right? These different layers of atmosphere of the earth have different refractive indices. So whenever, suppose here is an object, and suppose I can expect that there is a ray of light which wants to reach the earth, it will not travel in a straight line. Why? Because these light ray has to travel through different media having different refractive indices, so it will undergo bending. Sometimes it will bend towards the normal, sometimes away from normal, right? And after so much of movement it will reach the surface of earth, or we can say that it bends like this. Overall effect, we can show that it bends like this and reaches the surface of the earth, due to which this object is actually over here, but we see it raised over here. When I draw a line for the image like this, the object now I can see here the image of this object. So these objects appear raised. This is now exactly similar to the refraction that is caused by rectangular glass slab. In rectangular glass slab, what happened was lateral shift. This is somewhat similar to lateral shift only. This object appears raised. This object appears raised over here, and this effect is known as refraction. But this refraction is caused by whom? It is caused due to the atmospheric conditions. So the refraction for which atmosphere is responsible or atmospheric conditions are responsible, such refraction is known as atmospheric refraction. The refraction or the bending of path of light that is caused due to atmospheric conditions is known as atmospheric refraction. I hope this explanation is quite clear to you. Now let us see what is given in the textbook. See, this is one of the examples of atmospheric refraction. Especially in summer, when we are driving a car and going on a highway, we feel that just a few meters ahead of us or away from us, we can see that there is water on the road. Now, actually, there is no water on the road, but we feel so. When you see near about you, you see no water over here. But at few meters away from us, we see that there is water on the surface. Now, when we actually reach over there, we again find that there is no water. So actually there is no water, but we feel so that there is water present on the surface. We can see images of the objects over here. You can see this tree, its image is over here. This phenomenon is known as mirage. This phenomenon is known as mirage, and mirage is one of the classical examples of atmospheric refraction. Mirage is one of the examples of atmospheric refraction. Similarly, we are having many examples. For example, twinkling of stars. Atmospheric refraction is responsible for twinkling of stars. The sunrise and sunset are 2 minutes earlier and 2 minutes delayed. The reason behind that is atmospheric refractions. Right, now let us see what is given in the textbook about atmospheric refraction. Yes, don't be confused. Mirage is not given in your syllabus for now. I have just mentioned it as an example. So don't be confused. We will not study this. It is not given in our textbook. This is just a hint, just an example, so that you are clear about what do we mean by, or an example of phenomena that are arising due to atmospheric refraction. Fine. Now let us read. When the physical conditions of a refracting medium are not stationary, right? These words are important. Physical conditions of refracting medium are not stationary. Here, instead of refracting medium, we can take the example of atmosphere. Right? We can take the example of atmosphere. The physical conditions of the atmosphere are not stationary. So now this is quite clear. The atmosphere is not stationary. It is a constantly changing. For example, the temperature at the day is different from the temperature at the night. Sometimes there are more dust particles in the atmosphere, sometimes there are less. Sometimes it rains suddenly, sometimes it doesn't. Sometimes it is a clear atmosphere, there is no cloud, sometimes there are many clouds. So atmosphere is not constant, it is not stationary, it changes continuously. Due to this, the apparent position of the object seen through it changes continuously. Right, so now whenever we see something through the atmosphere, the position of that object changes continuously. Now, what do we see through the atmosphere? Suppose here it is Earth, and here I am having a star, and between the Earth and star, there is what? There is atmosphere. Now, when I watch something from here, and if atmosphere comes in between, the position of this object changes continuously. Right? Actually, the object is there itself, its image, the position of the image changes continuously because the refractive index of the atmosphere also changes continuously. Fine. So Earth's atmosphere is not stationary, it changes continuously at different places depending upon the surroundings. Now this is the reason why Earth's atmosphere changes continuously, because different places have different surroundings. The atmosphere that is in Gundal is due to our surroundings. We are landlocked. So our atmosphere or temporary atmosphere is so in a particular region. Now if you go to Somnath, if you go to Veraval, if you go to Jamnagar, if you go to Diu, the climate, the atmosphere over there will be quite different. Why? Those are sea areas. Fine. So definitely the climate over there will be different, and there would be slight changes in the atmosphere also. Fine. So different places have different atmosphere which changes continuously due to their surroundings, and thus refraction is caused by Earth's atmosphere. This is called atmospheric refraction. So simply, the refraction that is caused by the atmosphere is known as atmospheric refraction. When an object is seen through a turbulent stream of hot air rising above fire, we observe apparent random wavering or flickering of objects. Now, some of you might be having doubt in mind, some confusion that, sir, here we are talking about atmosphere. Now, somewhere we are talking about this hot air and fire and flickering. We do not get this. See, understand, my dear friends, this is an example to explain you something. Right. What we are trying to discuss is a very broad idea which I will explain it to you over here. Suppose this is Earth, right? And these are some layers of atmosphere around the Earth, right? So surface which is near to Earth will have different temperature, and the layer of atmosphere over here will have different temperature. Now due to this temperature difference, their optical density will be also different, and due to this difference in the optical density, there will be different refractive indexes also. Fine. So ultimately the refractive index of different layers of atmosphere depends upon temperature. Right, I will write it over here so that you get a clear idea. The refractive index of atmospheric layers depends upon their temperature. Based upon their temperature, they will be optically denser or optically rarer, right? And for that, we are seeing an example that when an object is seen through a turbulent stream of hot air rising above the fire, we observe apparent random wavering or flickering of objects. You have seen this many times. Just when you burn something, or just when there is a flame, and when you just observe above the flame, you see flickering of the objects. I will speak in normal language, the local language. ઘરે જ્યારે મમ્મી રસોડામાં કંઈક બનાવતા હોય, સપોઝ તમારી પાસે ગેસનો સ્ટવ છે, એની ઉપર એક વેસલ છે, અને એ વેસલની અંદર કંઈક બને છે, અને સમ હાઉ એ વેસલ કવર્ડ નથી, તો એ વેસલમાંથી સ્ટીમ્સ બહાર નીકળતી હશે. હવે તમે એ સ્ટીમ માંથી ત્યાં જોવો ને બીજી બાજુ તો તમને એવું લાગે ત્યાં મૂવ થાય છે સામે. તમે નોર્મલ લોજમાં ઓર રેસ્ટોરન્ટમાં જ્યારે પેલો પરાઠાનો તવો જોયો તમે જેની ઉપર પરાઠા બનતા ઓર ઢોસા ખાવા ગયા હોય તમે, રાઈટ, એ સરફેસ ઉપર ઢોસા બનતા હોય તો એમાંથી સ્ટીમ નીકળતી હોય અને તમે જ્યારે એ સ્ટીમ માંથી કોઈ સામેની વસ્તુ જો તો તમને એમ લાગે કે સામેની વસ્તુમાં કન્ટિન્યુઅસલી એક મૂવમેન્ટ છે. એ મૂવમેન્ટને આપણે શું કહીએ છીએ? ફ્લિકરિંગ ઓર વેવરિંગ. આઈ હોપ ધીસ એક્ઝામ્પલ ઇઝ ક્લિયર. તમને આ ક્લિયર હશે અને વધુ ક્લિયર બનાવવા માટે આઈ વિલ શો યુ અ વિડિયો, right, through which it will be clear what do we mean by wavering or flickering when we observe something through a stream of hot air. Let us now see that video. So now in this small video we will see that this is fire and we will try to observe the things through a turbulent stream above this fire. Just watch this video. I will not speak anything. Just clearly observe this video what happens. See, just observe outside the window. You can see flickering of objects over there. We see flickering of objects over here. I will play it once again. Sorry for the interruption. Yes, let us see. Surface above the fire. Turbulent stream is over here, and when we see behind this, outside the window, when we see through this turbulence, we can see that everything is moving. Flickering, actually, we call this. Right, this happens regularly. This is flickering. Why this flickering occurs? Due to the difference in the temperature through the medium in which we are seeing or through which we are seeing, right? So here is the reason for it. The air just above the fire is hotter than air further up, right? The air which is just above the fire is hotter than the air which is further up. So this is quite normal and natural. Suppose this is the fire source and these are the streams which are coming out. So here the temperature is more and the surface over here, its temperature will be less, right? So there is a temperature difference, and based upon this temperature difference there will be difference in the refractive indices also. If temperature is more, optical density will be less. If optical density is less, the refractive index is less. Similarly here, if temperature is less, the refractive index will be more. So there is a difference in the refractive index, and due to this there is continuous bending of light which is responsible for flickering. So the hotter air is less dense than cooler air above it, so its refractive index is slightly less than the cooler air. Refractive index of whom? Refractive index of hotter air, right? Refractive index of hotter air is slightly less than refractive index of cooler air. This causes refraction of light passing through the air. What causes refraction of light? The difference in the refractive index. But the physical conditions are not stationary, due to which refractive index changes continuously, and hence we see flickering of objects due to atmospheric refraction. We have already understood this sentence. Examples of atmospheric refraction: twinkling of stars, early sunrise and delayed sunset. These all are examples of atmospheric refraction. Twinkling of stars is one of the frequent examples of atmospheric refraction that we experience in our daily life. Fine. So one thing should be clear in your mind, right, about the atmospheric refraction. This is actually twinkling of stars, but before that I would like to mention that what causes the atmospheric refraction. Atmospheric refraction. What is the prime reason? Difference in refractive index of atmospheric layers, and this difference is also not constant. It changes continuously, due to which we see flickering or we see the effect of atmospheric refraction. And one of the examples that we have now is twinkling of stars. Right, so we very well know how the stars twinkle. You can see on your screen the stars are twinkling, and the reason behind it is atmospheric refraction. So let us now study how do the stars twinkle or why stars twinkle. The animation that you will see now on your screen is prepared by me. I hope you like that. It takes quite hard work, but let us see how it works out. So let us study the twinkling of stars. See, this is the surface of the earth. Suppose we consider that this is the surface of the earth, and from the surface of the earth we are trying to observe a star. So this is a star which we are observing from earth over here, right? This particular guy is observing the star. Now the star is actually present over here, but when we see from the surface of the earth, we see that the star is over here, slightly above the original position. So actually we never see this. We always see the image that is formed over here. But in particular, in originality, the star is present over here. So this is the actual position of the star. Actual position of the star. Right? We observe the star standing here on the surface of the earth. This is the entire earth. This is quite large object over here. But just consider that we are present on this earth and we are observing the star which is quite high. Fine. Now what we have studied is there are different layers of atmosphere around the earth. Right. So let me display. Suppose this is one of the layers. Then this is another layer. One more layer. These are the different layers of atmosphere, transparent layers around the earth. Fine. Now what is the thing over here that the refractive index of these layers is different. The refractive index of these layers is different. Now consider that this outermost layer will be near to this, or the light is supposed coming from the star. The temperature around the star, or suppose somewhere there is sun also, the temperature around the stars as sun and sun will be quite more than the temperature at the surface of the earth. That is for sure. On the surface of the earth, what is the temperature? What is the temperature that we feel around us? 40 degrees Celsius, 50 degrees Celsius. Suppose when we talk about surface, suppose 60, 70 degrees Celsius. But the temperature of these stars and sun, they are in thousands of degrees Celsius, 2000 degrees Celsius, 3000 degrees Celsius, 4000 degrees Celsius. Right? Their temperature is quite more. So definitely the atmosphere or the region that is surrounding the stars is having higher temperature, and as you move down, this temperature decreases. This temperature decreases. Fine. So what I can say that here the temperature will be more near the sun and star, and on the surface of the earth here the temperature will be less. Here temperature is more, here the temperature is less. So if temperature is more, I can say that this is an optically rarer medium, and near the surface of the earth I can say that there will be an optically denser medium, right? Because the temperature is less. So if this is an optically rarer medium, the refractive index over here will be less, and the refractive index over here will be more. Now this is in a phased manner when I compare them. For example, if I compare this and this, right, this is suppose medium 1, this is suppose medium 2. So here refractive index is less, here refractive index is more. When I compare these both, when I compare these both, the refractive index of this will be more and the refractive index of this will be less. When I compare these both, the refractive index of this layer will be more and refractive index of this layer will be less. I hope this is clear to you. So when you move from top to bottom, right? When you move from star to the surface of the earth, the refractive index decreases continuously, right? The refractive index increases continuously. Here there is less refractive index, here there is more refractive index. So when you move from the topmost layer towards the surface of the earth, the refractive index increases continuously. Don't be confused regarding this. The refractive index increases continuously. Now, if the refractive index increases continuously, whenever the medium over here will change, medium or in the sense refractive index will change from one layer to another layer, the path of the light will also bend. Let us see how. Let us consider that suppose this black portion that you are seeing over here is medium 1, suppose, and this portion that you are seeing over here is suppose medium 2. So now we already know that the refractive index of medium 1 is less and refractive index of medium 2 is more. Now suppose consider an incident ray, or first of all consider a normal at this surface, and suppose a ray is incident over here like this. What do you think? Here this ray of light is traveling from a rarer medium to a denser medium, right? Medium 1 is optically rarer medium and medium 2 is optically denser medium. So what do you think? This ray of light will bend towards the normal. Fine. So like this, the ray of light is bending towards the normal. Fine. Again, this ray is incident for this surface. This will be again considered as an incident ray. So again we can assume a normal over here. Again, when I compare these both, here the refractive index will be less and here the refractive index will be more. So light will bend again towards the normal. I hope you understand this. Again, if you consider a normal over here, again the refractive index over here is less as compared to the refractive index over here, which is more. So again this light will bend towards the normal. You can see there is subsequent phase wise bending of light, and ultimately light enters into our eyes like this, in this direction. Fine, I hope this is clear to you. So what do we think? Where does the light comes from? Light originally comes from here. This is the bent path of the light, but finally when I see that light comes from over here, what I think is that light is coming from here. So star will be present somewhere over here because the final ray of light is coming from this direction. So what we feel is that star is present over here, and you see a star over here. So this is the actual position and this is the apparent position of the star. The star is actually present over here, but when we observe from the surface of the earth, we see that star is present over here. Actually there is no star over here. Fine. So the image of the star is slightly raised up. It is slightly raised above. This is similar to the lateral shift that we were observing in the rectangular glass slab. Fine. Similarly, there is a shift in the position of the star. Its actual position is over here, but its apparent position is over here, and from the surface of the earth we see it over here. Now still we haven't understood twinkling. We have just understood that the star appears over here. Now what happens is, just consider this fact. The refractive index difference between these layers is not constant. Suppose we take an example that here the refractive index was 1.3, here refractive index was 1.2, and here refractive index was 1.1, and we saw that the star is not here but here. Now after some time it is possible that the refractive index over here will become 1.31, over here will become 1.25, over here will become 1.01. Suppose in that condition the star is actually present over here only, but the apparent image might not be here. The apparent image might be here. Sometimes the apparent image is over here, sometimes the apparent position is over here, and sometimes the apparent position is over here. So now the star twinkles. You sometimes see that star is over here, sometimes star is over here, sometimes it is here, sometimes it is here, sometimes it is here. The position changes continuously because this atmosphere is not constant. The physical conditions over here are not constant. Fine. So this star, we feel like that it is twinkling. Sometimes it is appear over here, sometimes here, sometimes here, sometimes here. And this non-constantness of the physical atmosphere over here results into the twinkling of stars. Fine. I hope this is clear to you. One more thing I would like to mention is this is just for explanation as per the textbook. Actually, suppose the star is present over here, then the light ray is like this. Sometimes it comes like this also, sometimes like this and like this. So finally there is a curved path like this. Right? It is not necessary that each and every time it will bend like this. Fine? Actually something like this happens. But ultimately the path is bent towards the normal as a cumulative effect. I hope this is quite clear to you. Fine. So this is how stars twinkle. I hope you liked this animation. This has been prepared after so much of hard work by me. Fine. I hope this is crystal clear to you. The twinkling of stars. Fine. Let us now check out the answer. This is the answer that you have to write as per the textbook. Explain the twinkling of stars. Right. Explain the twinkling of stars. This is an important question. This diagram is compulsory. I request you to please pause the video and write this answer down in your CW. Please write this answer in your CW. Explain the twinkling of stars. I hope you have written this. Let us see one more question answer and study it also. The question is why planets do not twinkle. Right, why planets do not twinkle. See, this is the surface of the earth. Here there is star and suppose there are other planets also. Right, the stars twinkle when we observe from the surface of the earth, while the planets do not twinkle. Why? See, the reason behind that is stars are considered as point sources of light. Fine. While planets are closer to the earth as compared to the star. Right, the stars are far while the planets are closer. So when they are closer, they cannot be treated as point sources of light because they appear big. So they can be treated as collection of many point sources. They can be treated as collection of many point sources. Fine. Now these point sources might twinkle. This might twinkle like this might twinkle like this. This is twinkling like this is twinkling like this. But overall, when I see that, the net effect over here will be zero because all of them twinkle in different directions. So the net effect will be zero. Fine. So see the size of planets and stars, they are both big. Stars are also big in size, planets are also big in size. But the reason is that suppose here is a earth and here is a star, but planet is over here. So here the distance is more, here the distance is less. Due to this difference in the distance, these are considered as point sources of light, but these are not considered as point sources of light, but rather they are collection of many point sources. These all point sources twinkle, but overall cumulatively when I add their effects, the net effect is zero, due to which the planets do not twinkle while the stars twinkle. Right. So this is also an important give reason. I request you to please write this down in your CW. Number 9. Right. Please write this down in your CW. Alright. I hope you have written this. Let us now move ahead and understand one more example of atmospheric refraction. That is 2 minutes early sunrise and delayed sunset. 2 minutes early sunrise and delayed sunset. Now first understand this topic, then I will show a beautiful animation to you. Right. 2 minutes early sunrise. See, what is the duration of the day? In layman term, it is 24 hours, but actually actual duration of day is 23 hours and 56 minutes. Actual duration of day is 23 hours and 56 minutes. But what we feel is 24 hours. This is what actually happens. But what we feel is that the day is of 24 hours. The reason is that the sun, when it rises, we see it 2 minutes earlier, and even after setting we can see the sun for more 2 minutes, so those 2 plus 2 is equal to 4 minutes, right? Hence actually our day is of 56 minutes, but the sun, we can see the sun in sky for 4 minutes more, 2 minutes earlier and 2 minutes later, due to which there is a difference in the duration or timings over here. But why do we see a 2 minutes early sunrise or 2 minutes delayed sunset? What is the reason behind it? The reason behind it is atmospheric refraction. And my dear friends, this difference in the timing of the day is also responsible for the occurrence of leap year, right? We might understand that in detail again when we meet, but for now we will study about 2 minutes early sunrise and delayed sunset. Again the story is same. The story again revolves around two aspects: actual position and apparent position. The apparent position is different from the actual position, hence we see a 2 minutes early sunrise. And for now we will focus only on sunrise, then we will understand about sunset. Suppose this is the surface of the earth, the beautiful earth we can see on our screen, right? Suppose this is the surface of the earth. Now generally sunrise, where can we see the sunrise? Generally on hill stations or on picnic spots, right? We generally cannot visualize the sunrise at our home, right? But generally we see it on hill stations, fine. So just take an example. There is a couple who is newly wedded, નવા નવા લગ્ન થયા છે ભાઈ અને બેનના, અને ભાઈ અને બેન સપોઝ માઉન્ટ આબુ ફરવા ગયા છે. આપણે કોમન લેંગ્વેજમાં વાતચીત કરીએ આમ બી ઘણા સમયથી મજા આવે, બરાબર ને? નવા નવા લગ્ન થયા છે ભાઈ અને બેન તો ન કહેવાય, આ પછી ખોટું થઈ ગયું. છોકરા અને છોકરીના મસ્ત નવા નવા લગ્ન થયા છે. They are newly married, happily married, right? And they have went for honeymoon. Suppose they went to Mount Abu, right? And the sunrise point of Mount Abu is quite famous, even the sunset point also, right? So suppose બંને જણા સવારે મસ્ત મજાના તૈયાર થઈ ને કે આપણે સનરાઈઝ જોવા જવાનું છે, તો સવારના પોરમાં બંને જણા ઉઠી અને માઉન્ટ આબુના સનરાઈઝ પોઈન્ટ ઉપર જઈ અને ઊભા રહી જાય છે. તો આ બંને જણા ઊભા રહી ગયા, મસ્ત જો બેન ફોટો બોટો પાડે છે, સેલ્ફી બેલ્ફી, નવા નવા લગ્ન થયા હોય તો શોખ હોય ને, તૈયાર બૈયાર થઈ અને બંને જણા ઊભા છે કે ભાઈ આપણે હવે સનરાઈઝ જોવાનો છે. નાઉ વોટ ઇઝ સનરાઈઝ? જ્યારે સન હોરાઇઝન થી ઉપર આવે એને આપણે સનરાઈઝ કહીએ. તો આ છે હોરાઇઝન. શું છે આ? હોરાઇઝન. સપોઝ, બરાબર ને? હોરાઇઝન એટલે ક્ષિતિજ, તમે ગુજરાતીમાં એને કહી શકો કે જ્યાં તમને એવું લાગે કે ભાઈ આસમાન અને જમીન બંનેની જે બાઉન્ડ્રી જેવું તમને લાગે એને આપણે શું કહીએ? હોરાઇઝન, બરાબર ને? આવું તો તમે ફીલ કરેલું હશે કે ભાઈ આસમાન અને જમીન બંને તમને જ્યાં એક થતા હોય એવું લાગે, દેટ ઇઝ નોન એઝ હોરાઇઝન, જેને આપણે ગુજરાતીમાં ક્ષિતિજ કહીએ. સન અહીંયા નીચે હોય, ટાઈમ પ્રમાણે ઉપર 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 આવતો જશે. હવે જ્યાં સુધી અહીંયા સન હોરાઇઝનની નીચે છે ત્યાં સુધી રાત છે, ઇટ ઇઝ નાઇટ. જ્યારે ઈ હોરાઇઝનની ઉપર આવે ત્યારે જ દિવસ ઉગ્યો કહેવાય, ઓર એને જ આપણે શું કહી શકીએ? સનરાઈઝ, when the sun comes above the horizon. બટ થાય છે શું કે સન હજી હોય છે નીચે અને આપણને અહીં દેખાવાનું ચાલુ થઈ જાય છે. સન હજી છે હોરાઇઝનની નીચે, બટ આપણને હોરાઇઝનની ઉપર અહીંયા દેખાવા લાગે છે, એ બી 2 મિનિટ પહેલા, 2 મિનિટ્સ અર્લિયર, 2 મિનિટ પહેલા આપણને આ સન જોવા મળી જાય છે. ઓરિજિનલી અહીંયા છે. વોટ ઇઝ ધીસ? ધીસ ઇઝ actual position. And what is this? This is apparent position. હોય છે અહીંયા but દેખાય છે અહીંયા. એ બી કેટલી મિનિટ પહેલા? 2 મિનિટ પહેલા. Reason? The light ray which travels from the sun will not travel in a straight line like this. એનો પાથ તો આમ હશે, ક્લાઉડ આવી રીતના આમ ફરીને અહીંયા આંખોમાં જશે, રાઈટ. અને પછી આપણને આવી રીતના અહીંયા સન પહેલા જ દેખાવા લાગે છે. વધારે વ્યવસ્થિત રીતના આપણે પ્રોપર ડાયાગ્રામ્સથી સમજીએ, બરાબર ને. બટ એની પહેલા અહીંયા આપણે ફરી પાછું લખી નાખીએ that what is this? This is the actual position of the sun. But sun appears above the horizon 2 minutes earlier due to the phenomenon of atmospheric refraction. Let us see how. Again the story will be same. The rays of light are traveling from here to here, and there are different layers of atmosphere that are surrounding the earth. This is suppose the first layer, this is suppose the second layer, this is suppose third layer, this is suppose fourth layer, right? Many layers, and the refractive index of all of them are different. So what happens is when light travels from here to here, it will continuously bend and then enter into the eyes of the observer like this. Suppose this is the original direction or path of the light, but refractive index changes and light bends. Again light bends, and light bends. You can see it follows a curved path like this and ultimately enters the eyes of the observers. આની આંખે જો એક મોટી છે ને બીજી નાની છે, બરાબર ને. એ જે ત્યાં બી હોય, આપણે અત્યારે એ ચિંતાનો વિષય નથી. But you can see that this ray of light bends continuously. Bending of light is known as refraction. And why this bending occurs? This bending occurs due to atmospheric changes. Hence this is atmospheric refraction. So now what observer will feel? That ray of light is coming from this direction. The observer feels that ray of light is coming from this direction. So what they may find that the sun is present over here. The sun is present over here. So what is this? This is the actual position. And what is this? This is the apparent position. The sun is yet below the horizon, but it appears above the horizon with a gap of how much minutes? 2 minutes. એને હજી અહીંયા પહોંચવાને 2 મિનિટની વાર હોય, એની પહેલા જ હોરાઇઝનની ઉપર દેખાવા લાગે છે. સમજાય છે? So this is the reason for 2 minutes early sunrise. Sunrise actually જ્યારે થાય એની 2 મિનિટ પહેલા જ આપણને સન હોરાઇઝનની ઉપર દેખાઈ જાય છે. I hope this is clear to you. The same happens at the time of sunset. સનસેટમાં ઊંધું વિચારો કે સન હોરાઇઝનની નીચે વયો ગયો છે, બરાબર ને. સનરાઈઝ છે ને એ 2 મિનિટ અર્લી હોય, 2 મિનિટ વહેલું દેખાય. સનસેટ 2 મિનિટ મોડું હોય, એટલે સૂરજ આથમી ગયા પછી બી 2 મિનિટ માટે આપણને હજી દેખાયા કરે છે. રીઝન? અગેન એટમોસ્ફિયરિક રિફ્રેક્શન. ઊંધું માનો, માની લ્યો સન અહીંયા પહોંચી ગયો છે નીચે, સન હોરાઇઝનની નીચે વયો ગયો છે, બટ છતાં તમને અહીંયા ઉપર દેખાય છે. અલ્ટિમેટલી વાર્તા તો એ જ છે કે સન હોરાઇઝનની નીચે છે છતાં બી તમને ઉપર દેખાય છે. ફેર એટલો છે કે સવારના ટાઈમે એને ઉપર આવવાનું હોય, તો જે સમયે અહીંયા હોય એના કરતા 2 મિનિટ પહેલા તમને ઉપર દેખાઈ જાય છે. ઇન ધ સેમ વે સાંજે સન અહીંયા નીચે વયો ગયો છે, સન એકચ્યુઅલી છે અહીંયા, બટ તમને હજી અહીંયા હોરાઇઝનની ઉપર દેખાયા કરે છે. કેટલી વાર માટે દેખાશે? 2 મિનિટ માટે વધારે હજી તમને સન દેખાશે, રાઈટ. તમને હજી 2 મિનિટ માટે સન વધારે દેખાશે. જેમ તમને સવારે 2 મિનિટ વહેલો જ જોવા મળે છે, એમ સાંજે 2 મિનિટ તમે એને મોડે સુધી જોઈ શકશો. The phenomenon at both the times is same, and that phenomenon is atmospheric refraction. I hope this is quite clear to you, right? હવે મસ્ત આ બંને માઉન્ટ આબુથી ફરીને પાછા ગોંડલ આવી જશે. હવે આપણે એની ચિંતા કરવાની જરૂર નથી. ચિંતા કરીએ આપણે ક્વેશ્ચન અને આન્સરની. Right, we see 2 minutes earlier before it arrives at horizon, and 2 minutes later before it leaves the horizon. So this is the answer that you have to write. This is the image that is given in the textbook, and this is again a very much important question. Right, explain the reason for 2 minutes early sunrise and 2 minutes delayed sunset. right? The sun is actually below the horizon, but due to atmospheric refraction, this path gets bent, and what we feel is that sun is over here. So we see it 2 minutes earlier at the time of sunrise and 2 minutes later at the time of sunset. This is the answer. I request you to please write this answer down in your CW. Fine. So now we are just one topic away from the completion of the chapter. Today it's Saturday. Fine. Sunday there will be a break, and Monday again in evening we will have the video lecture, right? And we will try to finish the chapter in that particular video lecture. We are now lagging behind with only one topic, that is scattering of light. If you remember, we have discussed this in chapter number 10, that there are many phenomena associated with light like reflection, refraction, absorption, dispersion, that we have seen in this chapter, then scattering, diffraction. In this chapter we will also learn about scattering of the light in the next video lecture. Fine. So please write this answer in your CW. Today we have written 3 answers in the CW, number 8, number 9 and number 10. Please write that in your CW. Fine. So here we end our video lecture. Thank you very much for listening and watching, and we shall now meet in the next video lecture on Monday. Till then, take very good care of yourselves. Goodbye.